welcome back to this channel. In this video, we're going to discuss about the basicity of amines. So let's start. In semester 1, we already learned about the definition for a base. Basically, base is an electron pair donor. So if the base is easy to donate electron, so means that the basicity is greater. So then why the amine can be a base? Because there is a presence of lone pair electron on the nitrogen atom. So our focus will be at the lone pair electron at nitrogen atom. So generally, there are two factors that will going to affect the basicity. The first one is the inductive effect, at where we will discuss about EDG, electron donating group. The example of electron donating group always is the alkyl group. While another one is EWG, electron withdrawing group, which is the halogen and also the NO2. And then the second factor that we're going to discuss will be the resonance effect. Basically, we will relate with the presence of the benzene ring. Okay, so let's start with the discussion of inductive effect. Aliphatic amine basically is a stronger base than ammonia because aliphatic amine consists of the alkyl group. Okay, so the alkyl group, like we mentioned before, this is an electron donating group which will increase the electron density on the nitrogen. So since the lone pair, the electron density at nitrogen is greater or increasing, so the lone pair electron will be easier to be donated. So from this statement here, we know that we can do the conclusion that EDG increase basicity. Okay, if let's say we have another condition, let's say we have propanamine and also N-methyl propanamine. So when we look at this, the name of the structure here, we know that propanamine, there is one alkyl group, and then for N-methyl propanamine, they will have two alkyl group. One is methyl, and then another one is propyl. So if we have more alkyl group, so also will increase the electron density at the nitrogen atom and make the electron pair at nitrogen atom easier to be donated, at where basicity increase. So if you look at here, you can notice that when we mention about EDG, okay, when we mention about EDG, here also we will relate with the electron density on nitrogen atom. Electron density on nitrogen atom, and then make it easy to donate electron, so easier to donate electron, and hence the basicity will be increased. Okay, as we mentioned just now, if the number of alkyl group increase, the basicity will be increased. This statement will only apply for the amine in the gas phase. Okay, in gas phases, basicity increase with number of alkyl group. So that's why we can see that primary amine is more basic than ammonia due to the presence of EDG. Okay, primary amine consists of EDG. Then we compare primary and secondary amine. The reason is because of the number of alkyl group. Similar case also happen to in between tertiary and secondary amine, also due to the number of alkyl group. Okay, however, if in the aqueous phase, the arrangement will have a bit different, at where the tertiary amine will come after ammonia. Okay, tertiary amine will come after ammonia. Why this happen? Even though tertiary amine have more alkyl group, however, it is less soluble in water. Okay, the term here less solvated can be considered like less soluble in water. When the tertiary amine is less soluble in water, is due, why they less soluble in water is due to they have more alkyl group. So when they less soluble in water, then the properties of basic is a bit harder to show off. So that's why in aqueous phase, tertiary amine is less basic than primary and secondary amine. So again, we do the conclusion. Why tertiary and amine is more basic than ammonia is due to the presence of EDG. Okay. Why primary amine has greater basicity compared to tertiary amine? The reason is because of the steric hindrance. Okay, which make it less solvated with water. Okay, then why secondary amine has higher, is more basic than primary amine? This one is due to the number of alkyl group. So always remember, after you arrange, when you want to do the explanation, try to explain in pair. Okay, besides looks at the number of alkyl groups, sometimes we also can focus on the pKb value. So just recall back in semester 1, the pH, the formula for pH is pH equal to negative log concentration H plus. So and then from here we know that if you always press the calculator, you will know that if the concentration H plus is higher, the pH value will be lower. So therefore, if we relate this with the pKb will equal to negative log Kb. Okay, so if Kb value is higher, means that pKb value will be lower. Kb value is the dissociation constant. So if Kb value is increased, means that it is more basic. So if more basic means that the concentration of OH negative is higher, which will lead to lower pOH value. So if the pOH value is lower, so the pH value is higher, so also means it is more basic. So just recall back the relation between the pH and pOH is pH plus pOH always equal to 14. So now we know that if the pKb value is the lowest, so means that the Kb value is the highest. And then, okay, we repeat again, when pKb value is the lowest, Kb value will be the highest, and then it is the most basic. Okay, this is the conclusion that we made. So in between all these, 3.25 pKb value will be the lowest. So and then this one will become the most basic. So when we look at the structure over here, ammonia has no EDG. CH3 and H2 have one EDG. CH3, CH2, and H2 also considered as has EDG. Both these only also have one EDG. Okay, then now we are going to look at it. Why the greater the number of carbon means that the alkyl group will push electron towards the nitrogen, and then make the, again you see the keyword electron density on the nitrogen become higher and easier to donate electron. So for here that then we can make a conclusion. The bigger the group of the alkyl group, so is the stronger the inductive effect towards the basicity. Okay, so now we are in the another factor. We're going to discuss another factor, which is the resonance effect. So before this have mentioned, if resonance effect, normally we can see there is one benzene ring in the structure. So at here also similar, the aniline also have a lone pair electron at the nitrogen. However, if you look at this statement here, the lone pair electron on nitrogen is delocalized. Delocalized means that the lone pair electron will not at the nitrogen all the time. It will delocalize means that they will going to moving. So moving to where? From here they mentioned that over the benzene ring. So we can refer the structure here. At first, the lone pair electron is at the nitrogen and then moving to here. Why here is negative charge? Because electron always negative charge. Okay, so the negative charge also is meaning the lone pair electron. So one moment it is at the top here, next moment it will be at the bottom here, and sometimes they will go back to the come to the left up here. Okay, and then next they will come back to the nitrogen. So that is why here we always mention the the lone pair electron is delocalized over the benzene ring. So when this happens, the electron density, you see again, we use the term electron density, will be decreased. Once the electron density is decreasing, so it will be more difficult for the nitrogen to donate electron pair and become less basic. So based on this slide, we can come out the conclusion, the resonance effect decrease the basicity. So just now, EDG increase the basicity, resonance effect decrease the basicity. Okay, now let's look at the question here. They already give us the PKB value, okay, and then also give us the structure, and then we're going to arrange them, okay. So from here we can see that the lowest PKB value is the 8.92, so means that this is the most basic, okay. So and then 13 is the highest PKB value, so means that this is the least basic. Okay, so I think they already arranged from this one is in the increasing order, A to B. Okay, is the increasing order. So when we answer this question, we want to compare in pair. So based on the first pair here, we can see that one have nitro and then have the Cl. Okay, so from here, we know that just now we have mentioned both of these are EWG. So from here, I think we can do the conclusion that NO2 is stronger EWG compared to the chlorine. So make the electron density, okay, is pulled further from the nitrogen. So electron density at nitrogen decrease. Okay, why decrease? So let's erase this one first. Okay, so why the electron density is at nitrogen is decreasing is due to NO3 is stronger. So when it is stronger, it will pull NO2. We can say that like pull lone pair, electron pair towards more towards to NO2 and make the electron density at nitrogen is decreasing. So when we look at the second pair in between B and C, this one have EWG and then aniline does not have EWG. Okay, so this one make them have different basicity. So the last pair is because of C aniline does not have EDG while D CH3 have EDG. And here we know that the EDG will increase the basicity. So in the next slide, we will look at the keywords that going to use when we want to do the explanation. Okay, as here mentioned, all the anilines A, B, C, D consist of resonance effect. So that's why we will not discuss the resonance effect in this question. So here they will mention that alkyl group is the electron donating group, and where again we can see electron density at nitrogen or on nitrogen atom. Okay, so that is why D is the most basic, the methyl aniline. Okay, then next they also let us know chlorine and nitro are electron donating group. And then this one again, after you just mention it is electron donating group or electron withdrawing group, just mention what will happen to the electron density at the nitrogen and then relate with the definition of base, easy or difficult to donate electron. So if difficult to donate electrons, so the basicity is less. Okay, then now here they mention again, like what we discussed just now, NO2 is stronger than EWG, is stronger EWG than chlorine. Okay, and then for the aniline, if you still remember, we remarked that there is no EWG or no EDG as well. Or if you want to simplify, you can just mention they doesn't show any inductive and resonance effect. Okay, now let's proceed to another example in your lecture notes. So we have two value, pKb, this one 3.36 means that this methyl amine is more basic. Okay, so why it is more basic? So when we compare the structure for the methylamine and ammonia, they consist of the methyl group, which is the EDG. So from here you can see methyl group is electron donating group, which will increase the electron density at the nitrogen. But this time maybe they didn't use the term increase the electron density, they just directly mentioned that electron density on the nitrogen is higher. So in other words, it's like increase electron density. So when the electron density is higher, so it's easier to donate electron. So that's why it is more basic. So I hope that when you look at this few slide, you already get the idea what are the keywords that is important when we want to do the explanation. Okay, another question. This methylamine consists of one electron donating group, while this one is N-methyl methanamine consists of two alkyl group. Okay, so again, they will mention that methyl is electron donating group. So dimethylamine have more methyl group, so have stronger inductive effect. So again, they will mention also the electron density on the nitrogen is higher. And therefore, the dimethylamine is more basic compared to methylamine. Okay, now we compare another pair. So for this pair now, the first one methanamine consists of EDG, while another one aniline consists of resonance effect. So let's check how we're going to explain this. So they will mention that aniline is less basic, okay, because we know resonance reduce the basicity, while EDG increase the basicity. So that's why by these two simple conclusion, we know that aniline is less basic. So because of the resonance effect, so that's why I think you have to mention the lone pair electron at nitrogen in the aniline is delocalized over the benzene ring due to the resonance effect. When the electron pair is delocalized, the electron density will become decreasing and become more difficult to donate electron pair. So that's why it is less basic. So if you are explained from the angle of the aniline. So another way look at it will be the methyl group. So if you mention the methyl group is the electron donating group, it will increase the electron density at nitrogen and make the nitrogen easier to donate electron pair. And it will become more basic. So since they are for this pair you have two factors, so will be depends on you which one you're going to use to in your explanation. Okay, there are no basicity question that can be found in the tutorial question. So that's why we are going to answer the ChemFriend question. ChemFriend question number 5. Arrange the following amine in the order of increasing order of basicity. So when we look at here, the first thing that we can differentiate these four is these three going to have resonance effect. Okay, while this does not have resonance effect. Then generally we already have the idea resonance will decrease the basicity. So if we want to increasing order means that this A is the most basic. Okay, and then for these three structure with the benzene ring, try to look at what's the difference. So the second B here consists of EWG methyl group, and then the C here does not have EWG and also does not have EDG. Okay, sorry, this one methyl group is EDG, yeah, it's not EWG. And then this one structure D NO2 is the EWG. So as we know, EWG will decrease the basicity. So means that this donkey is the least basic will come first. Okay, then in between B and also the C, B has the EDG, which will increase the basicity. So that's why will come C come first and then followed by B. So if we want to do the explanation for the structure D and C, we will focus that D consists of EWG. Okay, and then you explain relate with the electron density. I will not explain more details here. Okay, and then in between C and B, B consists of EDG. So you will comparing. Okay, and then another pair here will be the B and A. So when B and A is very obvious, B consists of resonance effect. Okay, so these are the things that we can go into explain. So for after you arrange, we will compare in pair. What's the difference between these two structure? Okay, ChemFriend question. Next question number 6. Also arrange in order of increasing basicity. So before we start, maybe we can draw the structure aniline with the benzene ring. So have the resonance effect. Okay, maybe I draw like this. Resonance effect. Yes, and then ethanamine CH3, CH2N, H2 does not have resonance effect. 4-nitroaniline, yes. Aniline 4 is opposite position, also have a resonance effect due to the presence of the benzene ring. 4-methyl-aniline, methyl CH3, this one also have the resonance effect. But then as we know, resonance will decrease the basicity. So among these four, A, B, C, and D, so we already get the idea due to the B does not have the resonance effect. So B is the most basic. Okay, then now we will look at EDG. Okay. A does not have EDG. Okay, so B have EDG, but we can ignore them because we already have the position for B. So and then C does not have EDG, and then D, yes, has the EDG. Okay, then the next one is EWG. A does not have EWG, C has EWG, and the D has no EWG. Okay, so from here, we roughly already have the idea. Just now we say B is the most basic. Okay, so EDG will increase basicity. So among these three, so definitely D has the EDG. So that's why it will have the is the most basic among these three. So we will put D over here. Okay, and then we know that EWG is decrease the basicity. So the one C with the EWG will have the is the least basic and then followed by the A. So if now we want to do the explanation in between C and A, C have EWG, so you have to mention structure C have EWG. Okay, if we compare A and D, these two pair, so we will mention that D consists of EDG, which increase the electron density at nitrogen and make nitrogen easier to donate electron. And then the last pair, which is in between the D and B, so D and B, the difference is the resonance. So we will mention that the B does not have resonance effect, which make it greater or have higher basicity. Question 7, arrange aniline. So again, we have a benzene ring with the NH2, ethylnamine CH3, CH2, and H2, and then triethylnamine CH3, CH2, and then CH2, CH3, CH2, CH3. So again, we use the weight resonance effect. Yes, no, no. Okay, EDG, no, yes, and yes. Okay, so for this one, ethylnamine basically is one alkyl group, but for this triethylnamine, from the name we already know there are three. So like before this, we know that the resonance will decrease basicity, while EDG is increased basicity. So from here, we can say that aniline is the least basic due to the presence of the resonance effect. Lone pair electron delocalized over the benzene ring. So and then next, the second higher will be the ethylnamine. And then the most basic is triethylnamine, sorry. I think I will use back the symbol A, B, and C. So the arrangement basically is follow the alphabet or the order, which is the A, B, and C. Okay, so when we do the comparison for the B, we can say this one has the resonance. Okay, and then this one have the EDG. Okay, but if we compare these two, both have EDG. This one C also have EDG. So we will mention number of EDG in the explanation. Okay, we come to the last question in this video. Also, we need to arrange the basicity. However, this time we are going to do the descending order. So also again, it's very obvious that all these three have the resonance effect. So means that we are going to looking at the EDG. So the first one does not have EDG. The second one, yes, we have one EDG. While for the third one, we have one EDG, two EDG. Okay, so here we consider we have more EDG. Okay, so EDG will increase the basicity, so that's why the arrangement is the 3 followed by 2, and then the least acidic will be the 1. So 3 and 2, the difference is 3 has more EDG, okay, compared to 2. While the pair between 2 and 1 is because of 2 consists of EDG, while 1 does not show any EDG. Okay, so I think that's all for this video. We already covered all about the basicity of the amines.